Hello everyone, welcome to another exciting math problem involving calculus and derivative. Many are confused about the two expressions shown on the screen. Here is the problem. Is the limit of the derivative as x tends to a from the right equals to the right-hand derivative. Before we uncover the solution, I encourage you to hit the pause button, grab your pen and paper and give it your best shot. When you're ready, feel free to share your answers in the comments. Then we'll explore the solution together. Let's get started. First, let's revisit the meaning of the expression on the left-hand side. It represents the limit of the derivative as x approaches a from the right. So, if we observe from the graph of f prime x, this is the value of the limit. On the other hand, the expression on the right-hand side is the right-hand derivative, meaning we are calculating the slope of the segment joining a fixed point on the graph with the x-coordinate of a to another point on the graph on the right side of a. Taking the limit, meaning we gradually move the point to the right of a closer and closer to a. Using this definition, it seems that the two expressions could be similar, but are they the same? We shall look at a few examples. In our first example, let fx be the absolute value of x. It is defined as x if x is greater than or equals to 0 and negative x if x is less than 0. With this definition, we know that f prime x is 1 if x is positive and negative 1 if x is negative. Note that we do not consider the value of x equals to 0. So we do not know if f prime 0 is defined. Based on this f prime x, its limit as x tends to 0 from the right equals 1. Whereas for the right derivative, using the definition, it is also 1. Hence, in this case, the values of these two expressions are the same. Next, let's slightly modify the definition of f. Let fx be x plus 1 for positive x and negative x for non-positive x. Hence, f prime x is 1 if x is positive and negative 1 if x is negative. Based on this, the limit of f prime x as x tends to 0 from the right is 1. Whereas for the right derivative, using the definition, it is infinity, or we say that the limit does not exist. Hence, in this example, the values of these two expressions are not the same. Let's examine a classic example. Let fx equals x squared times sine 1 over x if x not equals 0, and fx equals 0 if x equals 0. Using the product rule for derivative, f prime x is negative cosine 1 over x plus 2x sine 1 over x. Since the limit of negative cosine 1 over x at x tends to 0 plus does not exist, and the limit of 2x sine 1 over x at x tends to 0 plus is 0, it means that the limit of f prime x at x tends to 0 from the right does not exist. On the other hand, the right-hand derivative, which is the limit of x sine 1 over x as x tends to 0 plus, is 0. Hence, in these examples, the value of these two expressions are not the same. Based on the three examples we have explored, it is possible for the values of these two expressions to be the same, but it is not always the case. Sometimes the limit on the left-hand side does not exist, and sometimes the limit on the right-hand side does not exist. So we conclude that, in general, they are not the same. That wraps up today's lesson. I hope you found this video enlightening and that you are eager for more exciting mathematical adventures. Until next time, take care and bye-bye.